Okay, recording has started. Well, let me share my screen. So my screen is visible to all,
Yes.
Yes. Yes.
and
Yes. Yes.
I'm audible to all.
Yes. Yes. Yes.
Yeah.
Yes.
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 Yeah, thank you so much. So we are going to start. Yeah. So good morning, all of you. Me, Rajiv Shakya, welcome you to all in this wonderful session of the Kubernetes, and also would like to thanks to all of you to join this. And so I am super excited to deliver this session. I hope you guys all will be also excited to have this. So now, without wasting the time, we are going to start this session. So welcome once again in this session. So this session will be delivered, will be covered the things in two sessions. First session, which is going on from the 10 to 12:13. In this session, we will cover the theoretical part plus lab setup to do the practice. In the second section, which will be conducted in the evening, and it will be start from 6 to 8. In this session, we will perform all the commands and how to create the pods, how to create the replica set, and all the objects we will do it practically. Okay, so moving to the our next slide. So this slide is telling us what we are going to cover in this session. So we are going to cover here, we will discuss about the IT services, we will discuss about the virtualization, and what is the difference between the virtual machines and the container, and the Docker and Docker and Kubernetes, what is the difference? And we will discuss about the architecture of the Kubernetes and its component, and objects of Kubernetes. And we will also learn how to set up the Kubernetes cluster so that we can perform our the lab. And then we will do the perform the we will perform the lab, and after that we will deploy a website inside a pod, and we will try to access from our browser. So this is just like a small project. So after that we will get the a small session for the question and answer. If is there any doubt, then I will be happy to answer your doubt, your queries. Okay, so now move to the next slide, which is the first types of IT services. Basically, there are three types of IT services right now, which is IaaS, which is known as the infrastructure as a services, and PaaS, which is platform as a services, and SaaS, software as a services. So before discussing anything about the Kubernetes, we should have the idea about these services and the virtualization and containerization concept. So that's why, just to create the foundation, we are discussing about these types of the services and the topics. So I hope you will be more eligible to understand the Kubernetes after having the discussion on this. So so many people having the doubts and not able to differentiate between these types of the services. So I will let you know what is the basic difference between these services. So first one is the IaaS, which is infrastructure as a services. So in the infrastructure, we create a infrastructure means if you are creating a virtual server, if you are creating a server, that means you are creating the infrastructure for what? To so that your application could be run on that infrastructure. If you are creating a number of servers, or you are creating a data center, So that is known as the infrastructure. This infrastructure could be the virtual, it could be the physical as well, whatever you want. If you are creating the virtual machine over any kind of the public cloud like AWS and Google Cloud or the Azure, that infrastructure will be known as the virtual. Otherwise, if you are creating the infrastructure on your physical machines, that infrastructure that will be considered at the physical infrastructure. So I hope you were getting the understanding about the IaaS. So before discussing anything about the PaaS, we will discuss about the software as a services. So software as a service is what? Software is nothing but your application. Your application will run on the infrastructure. So if your application here, our application is what? Our application is the SBC node, MRF node, test node, HSS node. These are our application. These application will run on our infrastructure. So software as a services is what? Nothing. It is nothing that application which run on the infrastructure. Then question is that what is the requirement of PaaS? Platform as a services. What is the requirement? Actually, PaaS provide us provide the multiple functionality which is most important for the our application or our software as a services. It is very important. It provide the so many functionalities. We will discuss these functionalities later. So this is the platform as a services. If we will take the example, what are the example of IaaS? I have already told you. If we are creating the virtual machines or the physical machines, physical servers, this is the example. And installing the operating system on those machines, even either these machines are physical or the virtual machines. So that this till this installation of the operating system on the machines, it is known as the infrastructure as a services. If we are creating the platform, then we have the tools to create the platform on the infrastructure. So on the infrastructure, we are creating the platform. So to create that platform, we have some tools like Docker, Kubernetes, or Docker Swarm. These are the platforms which installed on the infrastructure to give the platform for the our applications. On that platform, you can deploy your application. So this complete services known as the software as a services. So moving to the next part, we will discuss about the virtualization. I think all the team members know the virtualization, what is virtualization. Even then we will discuss here about the virtualization. So as here written, the virtualization is a technique. Virtualization is a method to add or split the physical resources into the virtual resources as many as be required. So virtualization is what? Virtualization is not only the split, it is also to add the physical resources into the virtual resources. So what is the physical resources? So physical resources is nothing but this is the physical form of your system, hard disk of your system, memory of your system, CPU. So these are the system NIC card. These are the physical resources. If you have the large number of large size of the physical resources in your server, then you can virtualize this. You can split into the multiple virtual resources as per your requirement. So this is known as the virtualization. Why adding? Most of the people only know the splitting the physical resources into the virtual resources is known as the virtualization. So only not the split. Manoj, your mic is on, I think. Can you please mute it? Yeah, thank you. So adding and the splitting the physical resources. So we will take the example of the adding, and suppose you required a 200 GB or 200 TB hard disk in a single uh, resource. But in the market, as per my knowledge, you will not get the more than 50 TB hard disk. Okay, so what you will be do, but your requirement is 200 TB. So you will purchase the 50 TB hard disk, and you will virtualize all these four 50 TB hard disk and make it to 200 TB hard disk. So this is the example of the adding the resources and do the virtualization. And the split of the physical resources is, you all know very well that you have the large amount of the or large scale of our physical machines. We can uh, split into the multiple virtual resources or virtual machines, that is known as the virtualization in split. Okay, so basically there are two types of the virtualization is here. So first one is known as the hardware based virtualization, and second one is operating system based virtualization, as given in your slide, which is shown in front of you. So hardware based virtualization, we have some tools like OpenStack. OpenStack, which we are using in our organization, which is what? It is a hardware based virtualization, and it is the example of the infrastructure as a services. So OpenStack is providing the infrastructure for our application. VMware is also an example of the IaaS and the hardware based virtualization. You can install the VMware in your system, and you can create the multiple VMs on your system with the help of the VMware. Oracle VirtualBox and Microsoft Hyper-V, these are the example of hardware virtualization. Hardware virtualization means your physical resources like CPU, like memory, like hard disk will be virtualized into the multiple resources, virtual resources. So next is the OS-based virtualization. So we can see here the OS-based virtualizations example are given: Docker, Rocket, and Docker Swarm and the Kubernetes. We will understand about what is the difference between the hardware-based virtualization and the OS-based virtualization in the next slide. So we will discuss more about the OS-based virtualization in the next slide. So moving to the next slide, which is the difference between the hypervisor and virtualization. So first we need to understand what is the hypervisor. Hypervisor is a tool which can virtualize our physical resources into the virtual resources. So it's a tool. If you will talk about the VMware, then ESXi is the hypervisor name of the VMware. And if you will talk about the OpenStack, then KVM is the hypervisor. So these are the hypervisor. So now, what is the difference between the container and the virtual machine? Here in the left side, where my cursor is moving on, here you can see this is the example of the virtual machine, and here is the example of the containers. So if you will see, if you are going to hardware based virtualization, then you should have the bare metal and a fresh bare metal hardware. On that bare metal, you have to install a hypervisor so that this hardware can virtualize into the virtual machines. So the hypervisor will perform this task. After the virtualization, after the installing the hypervisor on the bare metal, you can create your virtual machines. Here you can see the three blocks, and these three blocks and these three blocks are your virtual machines. In your virtual machines, you can see here the guest OS is installed separate on this machine, and guest OS is the operating system. So operating system is installed in this virtual machine and is this virtual machine. That means you have to install the operating system on your all the virtual machines, because operating system is not available in your the bare metal, because hypervisor is directly installed on your bare metal, not operating system. So whenever you will create the virtual machine, then you have to install the operating system, and you have to specify the number of resources, how much CPU you required in your machine, how much memory is required, how much hard disk is required. At the time of the virtualization, you have to specify that. But in future, maybe it is not the it is not much use of that resource which you have already assigned to this particular virtual machine. So this is the wastage of your resources, because these resources have engaged, but application one is running, but it is not required much resources, but you have specified the large amount of the resources to this virtual machine. So this is the wastage of your resources. So this is the example of the virtual machine, how virtual machine look like. And in the right side, you can see this is the example of the container. The basic difference is here on the bare metal, a operating system get installed. A operating system on the place of the hypervisor, the operating system is installed, directly installed on the bare metal. And after that, a container engine could be anything. It could be Docker, it could be Rocket, it could be anything else. There are so many container engine available in the market, so you can install on the operating system. So first bare metal and then operating system. This is known as the host operating system here. And then the container engine. The container engine, what will do? It will create the multiple container like the virtual machine. And this virtual machine will not have its own operating system. It will have just only the footprint of the operating system, and the rest functionality of the operating system will be extract from the host operating system from here. So no need to install the operating system here. It will just keep this. This is the container. This is container one. This is container two. This is container three. So container will extract the operating system functionalities from the host system. So you need not to install again and again the operating system on your uh, container. So what is the benefit here? You can save your cost, because here you are purchasing so many operating system for the different machine, virtual machines. But here you are purchasing only once operating system for your host machine. So this is the cost saving. This is the difference between this and this. So I hope you will got understand the difference between the virtual machine and the container. So shall I
Yes.
push? Yeah. Okay. So moving.
Raj, you wait for a minute.
Yes. Yes.
Any query with respect to uh, virtualization and container and hypervisor? Any query, guys?
Yeah, hi.
Yeah.
Hi, Rajiv Mehtavi here.
Yes.
Okay,
Yes.
so for the virtual machine, for those VMs have a particular guest OS, how these OS get the memory allocation from the bare metal? How what size of operating the memory allocation required for the installing OS on this guest VM?
Okay. 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 Let me explain. You have performed the lab on the OpenStack when you do deploy the SBC. At that time, you give the path for the um, flavors. Flavor is what? Flavor is the combination of your physical resources, or you can say the virtual resources, where the mention the how much the memory is required for this particular VM in this flavor, and how much CPU is required. So that flavor you assign to your virtual machines like CFAT, DFAT, and something. So at the time of the creation of the virtual machine, you specify how much resources is required for this virtual machine. But it is not necessary in case of container. Okay.
Okay. So for this, I think there's a different type of hypervisor. We call it type 1 or type 2.
Yeah. Type 1 basically, I think type 2 is basically used for the practices or learning purpose, and type 1 is used for the industrial use. Okay.
So here we call it first one is type 1 visor, and the container one is type 2 hypervisor.
No. Both are the different things. Hypervisor is not there. You will see the inside the containerization, there is no hypervisor. So hypervisor is only for the case of the virtual machines.
Hypervisor is nothing but a technique through which you can virtualize your physical resources, right?
Yes.
Mehtab.
Yeah.
So okay, moving to our next slide, which is which tell us about the difference between the Docker and the Kubernetes. So many people's having the big doubt in the Docker and Kubernetes, and they understand Docker and Kubernetes both are the same, but in actual it is not same. Docker is an open source containerization tool which is used to create, deploy, and run the application. It performs the OS level virtualization as we have seen in our previous slide. Here, container engine is what? Container engine could be the Docker, it could be the Rocket, it could be the anything else. So Docker is what? Docker is a containerization tool. It with the help of the Docker, we can create the container, we can delete the container and all. But Kubernetes is what? Kubernetes is the container management tool. Kubernetes is used for the container management tool. Why it is required? It is required because the Docker is not able to manage the number of containers properly. If the large number of container is available, then Docker is not able to handle these. Docker is not providing the functionality to auto heal, auto scaling, load balancing, and the high availability, fault tolerance. These functionalities are not available inside the Docker. That's why Kubernetes comes into the picture. So Kubernetes provide the orchestration, and it's a management tool. Management for what? Management for the container. How it manages? It has the functionality, its functionality like auto healing. If your pod is getting down and it is not performing well, then the Kubernetes will delete that pod and create another pod in place of that. Auto scaling, you can scale up, scale down. The As we know, we have two types of the scalings, vertical scaling and the horizontal scaling. Vertical scaling is nothing but if you are scaling, if you are increasing the resources in your existing machine, that is known as the vertical scaling. And if you are increasing number of the pod or number of containers, then it is known as the horizontal scaling. So these are the functionalities which were provided by the Kubernetes. So this is the basic difference between the Docker and the Kubernetes. So moving to the next slide.
Hello, I have one died.
Yeah, please.
Please show me the last one slide.
This one.
Yeah, yes. Here
Yeah,
the what will be the Kubernetes in this picture?
in this picture. Okay. Actually, Kubernetes, I already told you, Kubernetes is a containerization engine. You can say
Okay.
Kubernetes comprise the functionality of the Kubernetes as well as the the container engine. So here you can sorry, this one. Here you can see the container engine. You can see you can understand this is the portion. This green portion is for the Docker under the Kubernetes.
Yes, means basically its meaning is same, correct? Not a different. That I am understanding. Hello, Raju bhai.
Yes.
Basically it's same, correct? Means
No,
technically it's
it's not
different,
same.
but
It's
at basic level we
functionality.
can understand it's the same. Huh?
No, it is not exactly same.
Okay.
But on this layer, you can understand here, on this layer, Docker and Kubernetes are working.
Okay. Okay. Understand.
Okay.
Hmm.
So we will discuss more about the the Docker and its history. As we already know, the Docker is a open source. Open source is what? Open source means you can get its source code from the internet and you can modify it as per your requirement. But if you will talk about the um, window operating system, it is not open source. You will not get the you will not get the source code of this Microsoft operating system. So this is not uh, the open source, but Docker, Kubernetes, Linux, all these are the open source. You can get the source code and you can modify as per your requirement, as per your requirement of your organization. So that's why it is known as the open source. So Docker is a tool to perform the OS level virtualization. I have already discussed. We have discussed about the OS level virtualization. Docker provides the OS level virtualization. Docker was first released in the March 2013, and it is developed by the Solomon Hike and Sebastian Paul in the year of 2013. It is written in Go language. Now we will discuss about the container. Most of people get confused in the between the container and the pod. Now currently here we will discuss about the container. What is the container? Container includes application. Application could be your SBC, your web server, or anything else. So container includes the application with all its dependencies. What are the dependencies? Here you can see in the picture that is depicted in your screen. Here there is a app. App means application, your application, it could be anything. And all the dependencies means for this app application, all the required platform, required uh, things like this, your application is required the Python, your application required anything else. So all the dependencies are comprised in the container. So dependence into the single deployable unit that can be used in the different system or server. So this container, if you will create the image of this container, then you can run that image on your system or the different physical server or the virtual server that could be run with all dependencies. You need not to install the dependencies in your system again as per the which is required for the application, because all the dependencies are included in the container itself.
Hello.
Yes.
So we can say this like all the software in one package.
Yes, all the dependencies of this application. Not all. There are thousands of the software in the market, but as per the requirement of this application, all the dependencies are uh, clubbed inside the container.
We can say like container is like an image, like an package. Like
Yeah, container is actually alive. If you will create the image, actually, if you want to move, if you want to do run this container in the other machine, then you will create the image first for this container. Then that image you can carry through the pen drive or the mail or something like that. You can run on the other system.
Uh, how modification take place inside the container if you make any changes?
If you want to make any changes, then you have to change in the image. You have to build your image with the Docker file. You can change all the required changes you can perform, and then you will create the image again. But inside the container, it is not possible.
Hello?
But inside the image, it is not possible.
Hello, Rajiv.
Yes.
Yeah, Rahul here. Actually, if I want to do some like interface modification and like for the configuration or IP management, so where we can change in that?
For that, you have to modify your source file from where you can you create the image.
Like no, from the image point of view, it is different. I'm talking about that Helm chart which we are using. Right? Helm chart,
Yeah, Helm chart.
Yeah, Helm charts we have to do the modification for that value YAML file and that thing. For the image point of view, it will be just to onboard your master and slave nodes, right?
Mhm.
Yeah, and for that the configuration and all the things that we need to do with that, it is from that any of how like any overview of that Helm charts for us. Is there
No,
anything
no.
you have
The
done?
Helm chart is different. It is not covered in this session. For Helm chart is just a package of the all uh, the required files and the directories. So this is the different thing, and it is used by the organization. But here we are getting the basic understanding about the Docker and containers and the Kubernetes.
Okay, Kubernetes. Like for this, is that there was a certification coming up, so it will be helpful. Or it will
No,
cover
no,
all
Helm is
topics
not
of this.
required. Helm is not required for the certification.
Okay, right. For the lab point of view, you are covering all the topics, right?
Yes.
Okay. Thank you. Okay.
Okay. Now coming to the Kubernetes, which is our topic today. So Kubernetes and its history. As we know, the Kubernetes is an open source container orchestration or the management tool, which automate the container deployment, container scaling, and the load balancing, which we have already discussed about it. Let's have a look at its history. Initially, it was developed by the Google. So we can say it is the product of Google. Kubernetes is the product of Google. But in Google, it was known as Borg, not Kubernetes. It was known as Borg. In the year of the 2014, Google donated the Borg to CNCF. CNCF is an organization which is Cloud Native Computing Foundation, and it is introduced as open source with the name of Kubernetes, and it is written in Go language. So this is the small history of this Kubernetes. Initially, it was known as the Borg, and it is developed by Google. It is written in Golang, and it is donated to the CNCF in the year of 2014. So this is the history. Kubernetes services provider. If we will talk about the public cloud, then Google have its platform as a services which is known as GKE, Google Kubernetes Services. Azure, in Azure cloud, it is known as AKS, Azure Kubernetes Services. If you will talk about the AWS, then it is known as EKS, Elastic Kubernetes Services. These are the platform as a services which is provided by the public cloud. If you will go for the Red Hat, the Kubernetes is known as the OpenShift. So there is no major difference between these. The small changes happens done by these provider. So if you will learn the Kubernetes, that means you can say I have the knowledge of OpenShift and the EKS, AKS, and all these things. There is a minor difference between the command line difference only. So about the Kubernetes. So
Yeah,
Kubernetes,
Raju,
yes.
which is the good for the learning?
It's as per my knowledge, it's learning for purpose. Kubernetes is okay because it's a
No,
base.
for Google, for Azure, and for OpenShift, what?
No, Kubernetes. I told you, no. Actually,
No, no.
Kubernetes is the base. Kubernetes is the base of all these platforms.
Okay.
Because Kubernetes is an open source. All these companies have take the source code from the Kubernetes and modify that as per their requirement and made these newer versions, you can say. So
Okay.
if you are learning the Kubernetes, that means you are learning all these things.
Like Linux had made a Red Hat had made a Linux
Yes.
modify.
These are the flavors
Mm,
of the Linux: Red Hat,
okay.
Ubuntu, CentOS, Kali Linux,
Yeah.
etc.
Okay, like that. This is the flavor of the Kubernetes.
You can say. Okay. So about the Kubernetes is a master and worker node based architecture. Here we will see the master nodes and the worker node. So it is the architecture based, which is master and the worker based architecture. And the combination of all the master and the worker node is known as cluster here. So all the combination of the master and all the worker nodes is known as the Kubernetes cluster. So in the next slide, we will discuss about the Kubernetes architecture. Here, here you can see the architecture of the Kubernetes. Here you can see the big three box. Here, Manoj, your mic is on. Please mute it. Okay, thank you. So here you can see the three big rectangles. This one is master node. This is the worker one, and this is worker two. In this picture, there is only one master and two worker here. In the actual scenario, in the real time industry, in real industry scenario, there could be a multiple master, there could be the multiple worker. But the sake of easiness, we are taking here the single master and the two worker node. So these nodes having some components, we will discuss about these components like scheduler, controller, etcd, API server, and then the worker node, the kube proxy, kubelet, docker. Docker is just a runtime engine which is used for the containerization. And you will see the pod here. So this is the basic architecture of the Kubernetes. We will discuss about all those components one by one in the next slides. So here,
Rajiv,
yes.
can you go back previous slide?
Yes.
Once again explain, please.
So this is the actually the architecture of the Kubernetes cluster. Here we are taking the one master and the two worker node. Master node is having four components. Its component which is scheduler, controller, etcd, API server, and the worker node is having its component kube proxy, kubelet, docker, and the pod. And these are the other things, the kubelet and web UI we will discuss later. So majorly master node having the four components, and the worker node is having is also the four components. Is it okay?
Raju,
Yeah, yeah.
Raju,
Okay.
it's okay. I have one question.
Mhm.
The Kubernetes and the Docker both are the different things. Then why inside the Kubernetes we use the Docker?
Actually, Kubernetes is not able to create the container. Kubernetes take the support of the containerization tool. It could be the Docker, it could be the Rocket, it could be the anything else. Separately, Kubernetes is not able to create the pod, create the
Means
container.
only just it is the management tool. Kubernetes.
Yes, yes.
Then we should learn both the Docker and Kubernetes. Both we need to learn.
You should have a small knowledge of the Docker. What is Docker? What is image? What is container? What is something like that?
Rajesh, hello.
Yes, yes.
Can we compare it with CVM and series? Like Docker, we can compare it with uh, CVM and
I'm not getting it.
actually, can we compare it with CVM and CVS?
No. CBM and CBIS are the tool or the platform of the OpenStack. CBIS is what? CBIS we can consider it as
CVS creates an infrastructure,
yes.
and Docker also, and Kubernetes is management tool, and CVM is also management LLC
We
management
can
tool.
understand like
Then we
Docker.
can compare like that.
CBM actually CBM manage the virtual machines,
Yeah.
not the container. That's why we cannot say the Kubernetes is same as the CBM.
No, we can understand like management
Yes.
and the infra tool.
Yeah.
Okay.
Okay, moving to the next slide where we will discuss about the different components of the master node and the worker node. So first component here is the etcd. Etcd is just a key value stored value, which is a database. Basically it keeps all the information about the cluster, how many master node are working, how many worker node are working, how many pods are working, how many replication controller and replica set and deployment are working. So all these information is kept by the etcd in the form of the key value store. It could be the inside the master, or it could be you can also configure it to the outside the master in the different on the separate node. So this is the etcd. In the scheduler, scheduler is responsible to schedule the pod and assign the node. There could be a number of nodes in our cluster. So which node is suitable for that particular pod? It is decided by the scheduler. So scheduler create the pod and assign the node to that pod, because that pod will be run on a particular node now. It could be on node 1, it could be on node 2, or it could be on master. So this work is done by the scheduler. In our next slide, the API server manager and the controller manager. So API server is basically it's an interface to interact between the master node and the worker node. So if any information is coming from the master node towards the worker node, then it will come from the API server. It will come from the API server. If worker node is want to send any kind of the information, if want to communicate with the master node, then the request will go to first to the API server, then it will be distributed further inside the master components. So API server is the between the interaction between the master and worker, and inside the master node, all the components will not communicate to each other directly. Here you can see in the picture, all the nodes are connected with the API server. If any information, if controller is required the databases, some data from the databases, then it will ask to the API server, and API server will ask to the etcd, then etcd will give the information as per the requirement, and then API server will forward it to the controller. So controller and scheduler is not directly connected to the etcd. So all the communication will happen through the API server only. And API server is also provide the interface to the end user to manage the things. If you are this is your cluster, and if you uh, want to take this the access of this cluster from the outside, from your system, from the other system, then you will contact to the API server only. You will not connect to the scheduler, controller, or etcd, or any worker node. You will connect directly to the API server. So API server provide the interface to connect from the outside, and it is also responsible to communication between the master and worker node. It is also responsible for communication between the components of the master nodes. So this is the API server. Now controller manager. So controller manager is what? Actually, controller manager is maintain the actual state and the desired state. Actual state and desired state means, suppose as per the requirement, there could be 10 pods can be run anyhow, but in actual only 9 pods are running. One pod got deleted. So controller will check our actual state is 9, but required state is 10. So there is a mismatch. So this controller give the instructions to the API server that actual state and the required state is not equal. So ask to scheduler to schedule a pod. So API server will give the instruction to the scheduler to schedule the pod. Then one pod will be created and the actual state and the required state will be equal. So this is the responsibility of the controller.
Okay, Rajiv, I just
yeah.
wanted to ask one question. How master node and worker node will communicate with each other through API server?
How master node and worker node? Yes, API server.
Okay.
Okay. Now we will discuss about the worker node components. We have covered all those 4 components of the master. Now we will discuss about the worker node components. So first component is the kubectl. No, kubectl is not the master node. Okay. Here kubectl, it is not the component of the master node and the worker node. So kubectl is what? Kubectl is the command line utility which provide the functionality so that you can connect with the API server, or you can interact with the master node, or you can say the cluster. So kubectl is not the component of any of the node, not either master or your worker. So it is the command line utility. So it provides the API server interaction. Okay, so all the commands you will perform, you will write to the kubectl, like here you can see the kubectl run nginx, kubectl cluster info, kubectl get nodes. So all the commands will be run through the kubectl. So this is
kubectl is the VM, Raju?
no, it's not a VM. It's a command line utility. It is installed in your.
What is the command line utility?
Command line utility means it is provide the support so that you can interact with the API server. Otherwise, API server will not recognize. Okay.
Okay, so we can call it it is a master of node.
Sorry.
We can call it kubelet to a master of each node, like each node having a there is a one man master who control the worker node.
No. Actually,
Because
if you want to take the access of your cluster, then this utility is required. And
no, then how we use this utility kubectl?
Sorry.
How we use this kubectl utility?
Suppose you
using
have
the VM, using the what? How?
No. Actually, you have your separate laptop. From your laptop, you want to access the API server. Then you have to install in your laptop kubectl. Got it?
kubectl is the application, I think.
Yes, you can say set of instructions.
Means this kubectl we can install in our laptop.
Sorry, what are you saying?
This kubectl we can install in our laptop.
Yes.
So why the
I can't connect with that.
So if you want to interact with your cluster through the API servers don't know you and your laptop. If you will install the kubectl, then only you can interact with the API server. Okay. Okay. Moving to the next, which is the Kubernetes worker nodes components. Here is the kubelet. Kubelet is the component of every worker node. So kubelet is, let me see the time. It's okay. It's only 1 hour. So kubelet is the component of the worker node. So it is known as the agent of the worker node. All the information of your worker will be kept by the kubelet, and it is provided to this information is provided to the master node. The information of your worker node, it is provided to the master node through the kubelet. That's why it is known as the agent of the worker node. If any information is coming from the master node through the API server, this API server will communicate to the kubelet, provide the information to the kubelet, then kubelet will circulate to the next component of the worker node. So kubelet is
Means the API server is directly connected to the kubectl,
yes,
kubelet.
kubelet, yes. And the kuproxy next component is the kuproxy. Kuproxy is providing the networking. If the one pod is want to communicate with the another pod inside the cluster, it could be the same node, it could be the on the different node. Then kuproxy provide that functionality. So it is used for the networking purpose to handle the traffic. So the most important.
Proxy, hello. The
Yes,
proxy can communicate with the kubelet first.
yes.
Okay.
So next component here you are seeing the Docker. Docker is not any kind of the component. Docker is just installed here to as a container tool. Okay, so component is basically kubelet, kubeproxy, and the pod. Here, pod is the endpoint where your application run. So pod is not just a logical boundary of the container. Basically, most of the people having the confusion between the container and the pods. So pod is nothing but the logical boundary of the container. Actually, Kubernetes says ki I don't know what is container. I know only the pod. If your container will be packed inside the pod, then only I can manage. Otherwise, I can't manage. So, for this, we can take an example. Suppose you are going to courier envelope to your friend or want to send to the location, and you use the courier services, and you are going to the DTDC courier or Blue Dart courier. So that envelope will be wrapped by the DTDC cello, DTDC tape or the Blue Dart tape. Then only, and they will apply the barcode as well. Then only they will manage that envelope. Without that tape and the barcode, they will not manage your envelope. So likewise here, the pod is nothing but the outer boundary of the container. So Kubernetes not manage the container. Kubernetes can only manage the pods. So inside the pod, there could be a single container, there could be a multiple container. It is up to you or your requirement. There could be a different scenario where we can uh, take the multiple containers in a pod, but usually single container run in a single pod. It is an ephemeral, means it is not permanent. It could be deleted anytime due to any kind of the reason. So that's why if it is got delete, then Kubernetes will create it again. But the IP address of that pod, it is not necessary to remain same. Suppose right now the IP address is here written 10.244.0.22. So if this pod got deleted, then it is not necessary to have this IP address again. So it will create, your application will be live, but could be the different IP address. So this is the pod.
Rajiv, the pod is like a VM.
Yes, pod is like a VM.
Okay, inside the VM, that container is installed.
Container, yeah, you can say the container is like a VM. Pod is just the packing material of Kubernetes, you can say.
Okay.
It is a box which is having the container.
But in the Kubernetes, we can say the pod is like a VM.
Yeah, you can say.
Because
Your
in the
application will run.
Kubernetes, there is no meaning of the container.
Yes.
Okay.
Okay. So we have discussed about the Kubernetes and its components, master node, worker node, and all the components which is resides inside the master and the worker. Now we will discuss about the Kubernetes objects, which provide the Kubernetes a very the functionality, so many functionality. So these resources, this is the command basically, kubelet API resources. When you will hit this command in your cluster, then you will get the number of resources. Few of resources are mentioned here, but there are so many resources which are not mentioned here. But we will discuss about about these resources. So pod, here you can see the pod, PVC, persistent volume claim, diamond set, stateful set, services, config map, secret, replication controller, replica set, deployment, namespace. All these are uh, the resources, or you can say the objects of the Kubernetes, which provide it the functionality, multiple functionalities. We will discuss about these. Here, RC, RS, deploy. RC is nothing but the replication controller, which we have seen here, replication controller. So RC is the short form of the replication controller, and RS is the replica set. Deploy is the deployment short form. So what is the purpose of these RC, RS, and deploy? It maintains the state of pod. We say the Kubernetes provide the auto healing, auto scaling functionality. So with the help of the RC, RS, or deployment, Kubernetes provide this type of the functionality. If any pod got deleted due to any reason, then this resource will create another pod on the place of that destroyed pod. So that's why the Kubernetes, so these resources are used to maintain the state of pod. If number of pods, suppose 10 pods are running, then it will ensure in any situation 10 pods keep running. So this is the RC, RS, and deployment. RC is replication controller. Its upgraded version is RS, replica set, and its upgraded version is deployment. So in the industry, deployment is in use. So one is more point is tent. Tent is what? Tent is to restrict pod creation on the specific node. Suppose your master node is very specific. You don't want to schedule any pod on that because it's a very crucial node. So in this scenario, you can tent that node so that the pod could not be created on that particular node. So this is the tent. Quota is what? Quota applied on deployment level and namespace level. What is the namespace? We will discuss later. So quota is nothing but there are two types of the quota. First one is the compute quota, and next one is the resource quota. Compute quota, in the compute quota, we mention, we provide the how much the CPU and how much memory minimum and the maximum requirement. As per our application, we can specify the CPU requirement and the memory requirement for the minimum and the maximum. And the resource quota is what? Resource quota is the pod inside a particular node or inside the particular namespace. How many pod can be created? How many replica set can be created? How many deployment can be created? This we can give the limit in for the particular namespace. We will discuss about the namespace. So services, next point is services. Majorly there are three types of the services which is used to communicate pod within the cluster and outside the cluster. So cluster IP is used for to communicate one pod to another. Then cluster IP will be used. If you want to access your pod services from outside the cluster from the internet, then you have to use the node port and the load balancer, because cluster IP is not capable to access, to provide the, to expose your application outside the world, outside the cluster. So these are the services which is used to communicate or to expose the pod or your application outside the your cluster. Roles is nothing but the set of instructions which allow a particular user to perform the limited commands. Suppose in the industry there are so many employees. We will create the role as per the role of that user. We will provide the role to a particular user to create the pod. We will not provide the permission to a particular user not to delete the pod. So something like that, you can say we can define the role for the particular user. So these things are the points.
Raju,
Yes, yes.
Raju, how we connect the cluster and the load balancer from the outside, from the Kubernetes? How we connect this?
Load balancer, it is a, we are talking about the here the internal load balancer. We are not talking about the external load balancer.
Okay.
Actually, it's the name of the service here. One more is the
Okay.
service which is I think headless. Currently, I am not able to recall what is the purpose of the headless, but majorly
Okay,
there.
just to be check this, the cluster IP or node, whatever we requirement, just to be check that in service.
I will explain it again
Okay.
in the lab
So can
section.
you explain again the RC and RS deploy and deploy?
Sorry.
RC, RS and deploy. Can you again explain this?
Yes, yes. In the coming slide, I am going to explain it again.
Okay, okay, thank you.
Okay. So RC, as I already told you, deployment is the upgraded version of the RC and the RS. So RC is what? RC, RS, and deployment is used for to maintain the state of the pod. If there are 3 pods are working, then anyhow the 3 pods will keep working. If the one pod is got delete, suppose pod number 2 got delete, then this uh, object will create an other pod on the place of pod number 2. So this is the purpose of the RC, RS, and the deployment. If you are creating a pod without the replication controller or replica set and the deployment, and then you will delete, or the pod got delete due to any kind of the reason, then it will not come again, because there is no um, maintainer is on the head of this pod. So this is the basic difference and the purpose of the RC and RS and deployment. So these are actually written in the simultaneously. Otherwise, these are the different objects. You can create the pod under the RC. You can create the pod under the RS. You can create the pod under the deployment. These are the different 3 objects. Okay. So we will perform the lab on these topics. Then you will be able to understand more. So basic difference between the RC, RS, and the deployment. There are some labels. If you are creating any object like replication controller, replica set, pod, then you can apply a label on that. Label is a just like you can say the name. So we will discuss about the label as well. So replication controller work on equality based selectors, labels and selector. Equality based means if we are using the equal sign or not equal sign to select the label, that is known as the equality based. And one is another which is set based label. So set based label is what? The keyword is thus for the set based is in, not in, exists. If we have multiple labels, if you want to choose, if you want to perform a particular task on a particular labeled pod, then you can choose the set based label. If you want to um, perform only a single, um, you can say on a single label, you can perform the task on a single label, then you can use the equality based. So set based is the advanced version of the equality based. That's why the replication controller is having the equality based, and the replica set is having the equality based as well as the set based. So deployment is also the upgraded version of all those. So deployment is also having the equality based and the set based labels. Why label is required? If you want to perform a task, suppose the label, we are giving the label to a pod name is equal to web, and out of 10 pods which are running in my cluster, 5 pods is having the label name is equal to web. I want to upgrade those pods, then we will take the support of the labels and selectors. We will hit the command where the name is web, then upgrade this version. So that kind of the use, the label and selectors got used. Okay. Services, which we have discussed about it. So there are 3 types of services: cluster IP, node port, and load balancer. Here, the cluster IP, I already told you, if the one pod is want to communicate with the other pod inside the cluster, then we use the cluster IP. In our scenario, if we will take the example of our SBC, there are 10 virtual machines are in the our SBC node. So these 10 virtual machines, VMs, or if these will be run in the inside the container, then it will be in the pod. Then one SC pod want to communicate with the CFAD or want to communicate with the DFAD. In that kind of the scenario, the cluster IP got used. So I hope you will got understand. For the internal communication, we use the cluster IP. Cluster IP is nothing but a particular IP which is used for all the cluster, all the nodes which are working inside the cluster for the master and the worker.
Only for use for the internal or for external also?
No, it is for the internal cluster IP.
Okay.
Okay, but suppose your pod want to expose outside the cluster, then cluster IP will not work. Then we have to use the node port. Node port expose your web, your services, your applications. You can access from the internet or outside the cluster. Suppose there is an application, suppose you have your website like facebook.com, and it is running inside a pod, but obviously you wanted to expose this outside the cluster to for the user from the internet. Then in that case, you will choose the node port service so that it will provide a port. So port range is default port range is from 30,000 to 32,767. A particular port will be assigned to all the nodes of the cluster through which we can access our application. So this is the use of the node port. I'm not going to read all these the text which is written here. You can read. I will provide it to you. So load balancer is what?
Hello, Raju.
Yes.
Like SBC can talk to MRF at that time also, like that, use the node port.
Yeah, if you want to communicate outside the cluster, then you use the node port.
Okay, between the other node.
Yes. If your pod is inside the cluster, then it is not required.
Okay.
Any of pod.
But I think SBC and MRF both are the different.
If SBC and MRF are within the cluster, within the same cluster, then it is not required. If these are on the different cluster, then it is required. Okay. So load balancer is what? In node pod, we understand. Let me explain with the help of MS Paint. I hope you people are not getting bored.
No, it's good.
It's very good so far.
Okay. So suppose there, oh, it is your cluster, and there is a master node, there are worker node, and worker node. So in case of the node port, a single port number is provided to every node. IP address, the node IP addresses of the nodes could be different, but port number will be same. So suppose port number is where is yes. Suppose port number is 30132. So this port will be assigned with all the IP address of the node. Inside these node, your pods are working like this, like this, like this, and this. These are the pod which are running inside your node. This is the master node. These are the worker node which are connected to each other. So if you want to access your application is running on these pods. Maybe suppose here 6 pods are running. The same application is running. So if you want to access it through the internet, then what you will do? You can take the IP address any of the node of the cluster. You can take the worker node IP address. You can take the worker 2 IP address, worker 3 IP address, or master IP address, and with the mentioning the same port number. So suppose you are taking the IP address of this is suppose 168.20. This IP address, then you can go to the browser to access this application. You can write inside the browser this IP address with the port number. Then you can access your your application, or you can say your website which is running inside this cluster. You can also take the IP address of this by mentioning the same port. You can also take the IP address of this node by mentioning the same port. But in this scenario, actually, I am creating the platform to make you understand about the deployment. So this is the scenario for the node port. So suppose this node become down and you have provided the IP address of this node to the end user, which are using facebook.com. But this node got down, then your website will not be reachable to that person because you have provided the IP address of this node which has got down. Then you have to provide the IP address of this or this. So to uh, recover this thing, the load balancer come into the picture. Load balancer will work like this. So all the IP address of your cluster will be mentioned inside this, and the single IP we can provide to the end user, which will be mentioned in the load balancer. I hope you people got understand what is the difference between the node port and the load balancer. Is there any doubt?
Yeah,
Hello?
load balancer. Can you explain one again, Raju?
But I have a doubt that how can port on master node and worker node could be same? Like
Yes,
on
yes.
one of the
But
master node, it should be different.
Port number.
because if port number is same, then how we will differentiate between master and worker?
Yes.
IP address is different for the all.
So according to
This is
IP address,
this
we
is the
will differentiate.
functionality. Actually, node port, you can say here with the name of the node port. Where is it? Node port. Node port means the port will be provided to every node of the cluster. Here there are 4 nodes that are working inside the cluster. Then the same port will be provided to the all the nodes, but IP address will be different for the nodes. Here could be the XYZ IP address, x.y.z.m. Okay, here could be the different, here could be the different.
Why not put number same for master and node?
So that we can
Node.
access our uh, our application from outside the cluster. Any of the IP address, any node IP address with this port which is provided by the service, we
So
can
this port defined there's all these worker and master node coming from the same cluster.
disturbance from Ram. Can you mute your mic, please? Thank you. Yeah, please tell me.
So they are the same node port means those worker node and the master node coming from the same cluster. So we mentioned as a identical port number
Yes.
for the uh, master node and worker nodes.
Yes, yes.
And as you one more thing, and as you told, all the IP will be available in the load balancer,
Yes, yes. We
and
will.
and and only one IP will be given to the end user, so that
Yes, yes,
okay,
yes.
okay.
All the IP of the our nodes will be mentioned in the load balancer, and the single IP will be provided to the end user. If
And
your
that
if
and
any of
then
the, let me complete.
okay,
If
okay.
any of node is got down, then there would be not the effect that IP address which is you have provided to the end user.
So we can say the one single IP that we will provide to the end user, that will be the IP of load balancer.
Yes, that will
Okay,
be the IP of the load balancer. Then load balancer will forward your traffic to the cluster.
okay, okay. Thank you.
Okay, okay. Now come to our presentation. Okay, so I think you have understand. So in this structure, you can see there are the service load balancer here. These could be the cluster IP node port and the load balancer, and this is applied on the RC RSR deployment, and under that the ports are working. So I have already explained all these things. So end user will come from the internet to the load balancer to the IP, sorry, to the service, and after that the service will take your traffic to the deployment and then the endpoint, which is pod. Okay, now we will discuss about the namespace. So namespace, what? Namespace is just you can say the virtual boundaries of the projects. So what is project here? Let me explain it again with the help of the MS Paint. Suppose you are working in an organization which is very big organizations like STL. STL have multiple clients like Nokia, like Ericsson, like IBM, like HCL. But HCL is providing platform as a services to their client. So STL what will do? STL do can two things. STL can create the cluster for the different the clients. STL can purchase the physical hardware separately for the Nokia. STL can purchase the hardware for the separate hardware for the Ericsson, HCL, or IBM. Or HCL can create a big data center and create a big cluster. So this is what? This is data center of STL. This is data center. And we have created a big cluster. But STL have multiple clients. So STL what will do? STL will separate these client with the help of the namespace. So namespace is nothing but is the separation, logical separation of our cluster. So here you can see, you can give this portion to the Nokia, this portion to the IBM, and so on. So this is the namespace. So namespace is the way to organize cluster into the virtual subcluster. So this cluster is complete cluster is virtualized into the multiple. Actually, this is the in the data center. This is the K8 clusters. K8 cluster and Kubernetes cluster. So this is the namespace. I think you people got to understand about the namespace. What is the namespace? Presentation mode. Okay, so now it is 11:30. We have 30 minutes. So in 30 minutes, we will try to set up a cluster for the practice purpose. And in evening session, we will perform the number of commands and to make it more understand. So you people need the how to create the cluster.
Yes.
Yes.
Okay. So for cluster creation in the K8s is nothing but it is the Kubernetes. If you will see, the 8 characters are exist in between the K and S. That's why it is written as the K8s. So for the K8 setup, you can set up it on the physical server. You can set up your Kubernetes cluster on the virtual machines or on the public cloud. For the physical machine, what you do, you have to go to the market and you have to purchase 2 to 3 server, and then you have to install these, and then you can create the Kubernetes cluster. But it is a very tedious task and very costly. For the virtual machines, you can use you can create the virtual machines on your system with the help of the VMware or Oracle box or etc. Then you can create the Kubernetes cluster. You can also use the public cloud like AWS, Azure, and GCP. You can also create the cluster on your public cloud. So for the sake of easiness, we are going to create the cluster on our AWS account. So for that, you should have the AWS account, as I already have the AWS account, which is this is, we are in Mumbai region. We will launch 3 machines, 3 instances. Instances is nothing but the virtual machines, which is known as here as instance in the AWS. So we will create this type of architecture, which we have seen in our presentation, 1 master and the 2 worker. So for that, we will launch instances. If anyone is having a problem to use how to use the AWS and like, then we will discuss later. You can reach me or ping me directly after the session. We will take 3 machines here, 3 machine, 1 for the master and 2 for the worker. We will here take the operating system CentOS 3, sorry 7, CentOS 7.
What is this CentOS 7?
It's the operating system. It's a flavor of Linux.
I think it's free.
Sorry,
It's free. CentOS 7 is a free.
it is
Yes.
not free. No, it is not free. You can see here the 0.012 dollar per hour.
Yeah, but different. They have a different other flavors also given, which is free.
Yeah,
You can
yeah.
use
You can use that. Like you can use your Ubuntu or
yes,
the
Red Hat also.
okay.
Red Hat
Yeah.
is free. I think 7.8 version is free.
Yes. So here we have to create a key so that we can access our virtual machine from our system, because these machines will be created inside the data center of the Amazon. We are here in Mumbai region, so we are going to create the key. We can keep the name as per our requirement. We are taking here the K8 as key. We are going to use through the, we'll take the access from the putty. That's why we will generate the .ppk key and create pair. The key has already downloaded. We will use this when we will take the access of the machine. Okay, so all things will keep remain and we'll launch the instances. Now view instances. You can see there are 3 instances have created, which is currently not in ready state. It will take few seconds. We will take it. One is as master. Second one is the worker.
Now, do all three VMs in same cluster?
Yes. Same reason.
Same, no? Yeah, same reason.
Still cluster is not created. We will create the cluster. Okay. So for the Kubernetes, master node should have at least 2 core CPU and the 4 GB RAM. But here we have taken the 1 core CPU and 1 GB RAM only. So it will not work. So we will increase the CPU and the memory size for the master node. Once it will get run, then we will stop master node again so that we can change its instance type. So we will stop this machine only for the master, not worker. So it is getting stop. Actually, this is the basic requirement for the master node. Okay, now it has stopped. We will change its instance type. For that, we have to go to inside the action instance setting and then change instance type. Here you can see we have taken the T2 micro, but in T2 micro only one CPU and 1 GB RAM is available. So we will take the T2 medium.
Hi Rajiv.
Yeah.
On that time, if we need the more space, so how will we increase the space of that machine? Suppose we are deployed to something, but we
Yes,
need
yes,
to.
by stopping your machine,
Okay.
you can change the size as per your requirement.
How we can change? Can you please tell?
I'm doing the same now.
Okay.
RST. Now our machine is T2 micro, which is having the 1 core CPU and 1 GB RAM. Now we will convert it into the T2 medium. Apply.
Raju, I think it's also chargeable.
Yes, T2 medium.
Medium.
T2 medium is chargeable.
Yes.
But for the practice purpose, we have to take this. There is no other.
Yeah, 5 to 10 minutes. Right? Yeah, half an hour.
Yeah. So you have to hit the multiple commands on the master node and the worker node to create the cluster. But I have prepared shell scripting for that, so it will not take much time. So I will give it to you all as well. So now we will take the access of our master node, and we have to change its security group as well for the all nodes.
Can we check? Can we check? Means it's as per our coins done or not? Means it is RAM size or hard disk is increased or not? Can we check that?
Yes, you can check.
From where?
I'll let you know. Just wait. Here we will allow all the traffic for the practice purpose, but in the industry you will allow only the traffic which is required only. All the machines we will do. We'll go to the security. It is already in the all traffic. Okay, no need to change. Let's check the third one. This is worker. Oh, 2. Inbound traffic. Yeah, all traffic is allowed. Okay. How to check it is change or not, right? Okay. If you will click on the master node, then all the details will be given here. Here you can see it is T2 medium right now. Okay. And you can also check the number of CPU. Yeah, here you can see the CPU are 2. Okay, Sunil, it's okay.
Yes, sir, Understood.
Okay. Now we will take the access of our master node. We will get ready master node first, then one by one we will get ready the worker node one by one. So you have to copy the IP address of the there are two IP address here, public and private. So we have to take the public IP address here, and we will open the putty. We'll paste the IP address of our master node, and we will browse the key which we have downloaded. That one is inside our download folder. Yeah, this key. Open. Accept. CentOS is the username. When you are taking the image of CentOS, then username will be CentOS. We will provide the sudo privileges. This machine sudo su and cd. Let me increase the size of this so that you can clearly see the font. I'm increasing the font size, and color I'm making it, the background color is white. Okay, now I think it is visible to you all.
Yes.
Okay. Now what we will do, I have the script. I have created the script to get it ready. I will make you understand all the steps, but I will perform this. I will run this shell script. In this shell script, you can say we will change the host name and set and for swap sed. With the help of the sed command, we will do the changes in the config file. And so all these the command set of commands. This is nothing but the set of commands. So this script will get ready our cluster. Okay. So currently, if you are saying your host name is what, if you will type here host name, then your host name is this. After running this script, the host name will change and will be ready for the here. We will install the Docker. Here we will install the kubelet and the kubectl, kubeadm. These are the instructions which is written inside our script. So we will create a file here, vi.
Yeah, Raju, this script is made by the deployment team or any other team,
No,
the
actually this
software team?
script is not for you all. If you are the Kubernetes administrator, then only you can you have to get the ready your cluster. This is
Suppose,
I'm explaining you just for
yeah,
your practice purpose, so that you can create your cluster by your own. Okay,
okay.
so we will press the I, and we will copy this script. This one. Control A, Control C, and we will paste it here. Now we will save it. If you will do ls, or you can say ll, then you can see here your master.sh, which is already created. But it is not, you can see here, it is not executable. If you are going to run the script, then your file should be executable. So we will give this permission for executable for chmod plus x means executable and the name of our file, which is master.sh. Now if you will do ll, then you can see it is executable. Here x and x is available, but before that it was not available. Okay, so now we will run this script. So by the sh master, now I will enter the I will hit the enter, then the process will start. Process should be start. So I'm pressing the enter. You can see here the process is going to be start. It is going on. It will take few minutes. Here you can see the Docker is installed. Docker is installing actually right now.
Uh, Hi Raju.
Yeah, yeah.
This lab you are using that is a paid version. So is there any lab there which is a free version where people can practice
It
on it?
is not. It is not much. In if you are using this lab for the 1 to 2 hour, then I think not more than 10 rupees or something like that. So it is
Okay.
not much costly.
Because termination is mandatory na. If you forget to terminate, it will continue to charge, right?
Yes, no need to terminate. If you will get it stop,
Yeah,
then
stop the
yes,
session, stop the session, right?
yes. So here you can see your master node is ready. Hit the above command in your worker node so that the cluster is on. So our master node is ready for this kubectl get node. If you will enter a mm, 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 there is some issue. Not be create. I think there is some issue in this. Kubernetes, PC Kubernetes, and not one. Yes. Okay. So likewise, I think there is some issue in this script, so I need to check. So likewise, we can create our the worker node. So for that, I will check it and let you know what was the problem. So for the worker node, you can run this script. So for this, you have to log in your worker node. So we will click on the worker and copy the public IP address, and we will open our key once again to take the access of the worker one.
Hi, Raju.
Yes.
Like those the worker and that server. What was the difference between the script of those both of the?
I will let you know what is written in
It's
the.
how. So what makes it the server and what makes it the server?
Okay, I will let you know.
What was the issue in last one?
In
Huh?
in what?
In last one, in Miss Master means terminal. What was the issue?
Actually, master is not able to communicate with the API server. So I have to check this. So this is not a big issue. I will let you know.
How you know that means it's not communicating?
Yeah, actually kubectl command is not running here.
Okay.
You will see the kubectl get nodes when it is not working. Okay, so this is the issue. Okay, ls, there is nothing here, so we will create a file for the worker 1.sh. Press enter. I think we should increase the font size so that you can see the properly. Change. Yes. Apply. Okay. Now you have to paste this script. The file is ready. Just make it executable as we have done previously. Chmod plus X and the name of the file, which is worker1.sh. Now we will do ll, then it has become the executable. Now we will run this sh worker one. We'll hit the enter. Yes, yes.
हाँ जी बताइए.
Manoj, your mic is on.
हाँ हाँ बोलिए.
Manoj, please mute your mic.
ठीक है ठीक है.
और आप चले जाइएगा सर, क्योंकि डॉक्टर कल मॉर्निंग में अवेलेबल रहेंगे.
Okay.
Hi Rajiv, I just wanted to one thing more. What version we are using in Kubernetes?
I think it's we will check here.
Where?
Currently, it is not working. Actually, kubectl command is not working. Whenever it will be work, then I'll show you.
Okay, sure. Thanks.
So your worker node is ready. What you need to do? Currently, it will not work. Otherwise, the master node, when you get ready, then it will give a key, a token, so that token you will run on your master node, sorry, worker node. Then that worker node will join the cluster. So where is this token? Cannot create directory.cube. Okay. Load balance failed. There is something failed. That's why it is not given. Okay. No issue. I will let you know. I need to check if I will troubleshoot, then it will take much time. So that token will be provided as a command. So you just need to that token like by this, and you have to run here like here. Okay. So by doing this, your worker node will join the master node, or you can say join the your cluster. So the same task will be performed on the other worker, which is worker 2. So you can do this likewise here. So I think you got understand how to create the cluster, but it is getting error, but I will resolve it and let you know what was the problem. So there is no issue at all. So till now, if is there any query, then you can ask, and in the evening we will perform the some task in our the cluster. One cluster I have already created in the different region, and I'll show you, which is in Tokyo region.
Raju, inside the node,
Mhm.
inside the worker node, how we can create the pod?
Inside the worker node, all the tasks will be performed through the master node. Okay.
Okay.
So master node will decide, so this pod where we need to deploy. You could have you could have the multiple worker node. You could have the more than 2, 3, 4, and 5. So it will decided by the master node scheduler.
In evening, you will show me the pod, how we make the pod.
Yes, in the evening we will create the pod, we will delete the pod, we will check the logs, we will number of commands we have, which we will perform. Here you can see these are the API server, get, node, get, pod, and these are the commands which are going, we will perform in the cluster. Okay, so let me show you which the cluster I have already created. Mm, Master worker. It is a working cluster. Just to show you how it will be look like. We are closing this. It is taking few seconds to get launch. Worker 2 is in running state. Master is also in running state. Yeah. So we will take the access of this machine, which is master node, with the help of putty, or you can also take the access from the mobile external. This is just the interface to take the access of the virtual machine, nothing else. In desktop, the key is this, accept CentOS. So to give the privileges of the root user in CD, let me increase the size of the font, change setting, appear, change color. Yeah. So if you will hit the command here, kubectl get node, then you can see there is a one master node and 2 worker nodes here, and version is available here. You can see here. I think someone is asking for the version. Okay.
Raju, now your kubectl is working. The
Yeah,
master node is working.
kubectl is working on. Actually, I have created another.
Okay, in
Cluster.
another zone.
Yes, for my practice purposes. So this is a ready cluster. So kubectl is working here. Kubectl get pod. It is working because pod is not available. That's why it is showing the no resources available. So rest command we will show in the evening session. If is there any question, then you can ask me, or you can and provide the feedback. How is our training? And now
how we know that our worker node has joined the cluster master node, the cluster?
if your worker node will not join the cluster, then if you will hit this command kubectl get node, suppose you have another worker node which is worker 3, and it is not, if kubectl get node, and if it is not joined, then it will not be reflect here. If it is joined, then it will be reflect as a worker node 3. Okay. And only
after the meeting, please provide your script.
Yes,
And,
sure.
Yeah.
Don't worry, I will help you how to get the ready the cluster for the practice. Okay. Now I'm stopping our recording. Stop recording. Stop.